Hello and welcome to Chapter 5, Section 2. Here we're going to talk about angle, side, angle, triangle congruence. This is used if only some of the parts of a triangle are identified as congruent. If you only have this information, it will still give you one and only one triangle. If you have an angle and an angle and the side that's in between, so it's angle, side, angle right in a row, this can only make one triangle. If this is all you have, you can confirm congruence. So using angle, side, angle to justify triangle congruence looks like this. If you know in triangle ABC and triangle DEF that A is congruent to D and B is congruent to E and line AB is congruent to line DE. Now you could slide or translate that so that triangle ABC, so that point A is on AD, and you can prove that those are going to be the same. Now they give you other sets of triangles, and those triangles, these give you the other ways that you can rotate or reflect the shapes so that the triangles map onto each other and you can see how ASA works. So take a minute to go through Explore 2. Deciding congruence using angle, side, angle. So the angle, side, angle, triangle congruence theorem is that if two angles and the included side of one triangle are congruent, then the triangles are congruent. So here we're given two angles and the inclusive side. Here we're given two angles and an exclusive side, and we have to find out if these two triangles are congruent. So it's given to us that angle C equals angle F, and they're both 61. And we know that A is 45 and E is 74, and the question is this 74 and this 45, which would make them congruent? And if you do the subtraction from 180, you can see that 180 minus 61 minus 74 is 45, which makes these three angles all congruent. And then having one inclusive angle, side, angle, angle, side, angle. So you've got these three that line up with these three. Because of that, you know that triangle ABC is congruent to triangle DEF. Pause here and look at B and see if you can duplicate that. Here we have triangle JKL and triangle MNP. And we know that angle M and angle J are congruent at 31, that line JL and line PM are congruent at 62. And the question is, does this angle equal this angle? So we do 180 minus 31 minus 110, that equals 39. So we realize that angle N does not equal angle K, which means that the triangles are not congruent. So pause here, try reflection question number 4, and your turn numbers 5 and 6, and come back when you're done. Number 4 is no. You only need to know that angle P and angle L are not congruent. As soon as you find one that's not congruent, then the whole triangles aren't congruent. Number 5, yes. Angle B is congruent to angle C. Angle D is congruent to angle D. And you know that line BD is congruent to line CD. 6 is no. You know that angle Q is congruent to angle T, and that line QR is congruent to line TU. And then the question is, does 72 and 67 and 38 make 180? And when you do the math, you discover no, that angle R and angle U are not congruent, which means these two triangles are not congruent. And now let's see how we can use angle-side angle theorem in proving triangles are congruent. Here we have given that this angle is congruent to this angle, and that this angle is congruent to this angle, and the question is, can we prove that these two triangles are congruent? Well, first we know these two because they're given. We also know that line QP is congruent to line QP because of the reflexive property. They are the same line, therefore it's congruent to itself. And that gives us angle, side, angle, angle, side, angle, which lets us know that these two triangles are congruent. Pause here, try B, and come back when you're done. Here it's given that angle A is congruent with angle C, and that E is the midpoint of AC. Prove that these two triangles are congruent. Well, we know that if E is the midpoint, then line AE equals line EC. So we've got what was given to us, and we've got that these two are congruent because that's the definition of midpoint. And we know that this angle equals this angle because they are vertical angles. And that gives us angle, side, angle, angle, side, angle. So these two triangles are congruent because of the angle, side, angle theorem. So pause here, try reflection number 7, and your turn numbers 8 and 9. Come back when you're done. Number 7, line CD equals 8 centimeters because of CPCTC. With number 8, we are given that this angle equals this angle and this angle equals this angle. We know that line LM equals line LM because of the reflexive property. And because of that, we know that these two triangles are equal because of the angle, side, angle theorem. With number 9, we are given that angle S equals angle U, and they're both 90 degrees. We are given that line ST and line TU are equal because that's the definition of the bisector. And we know that this angle and this angle are equal because of vertical angles. Therefore, these two triangles are congruent because of ASA. Pause here. We're on the elaborate questions, numbers 9, numbers 10, 11, and 12. Come back when you're done. Number 10, they will be identical if the side is between the two angles. But if it's a different side, you have to do other things. Number 11, vertical angles are congruent. Overlapping sides are congruent. Right angles are congruent. Also, you can tell by tick marks that you make, like this. And number 12, the side must be between the two angles. And your homework tonight is numbers 1 through 23. I'll see you next time.